By allowing for the on-demand production of custom plastic parts, desktop FDM 3D printers have enabled an immeasurable expansion in the accessibility of engineering and innovation. Unfortunately, many of the world's biggest problems cannot be solved using plastic parts alone, and instead will require the use of metal parts. For my science fair project, I created a machine capable of manufacturing parts out of almost any conductive material at a cost comparable to a desktop 3D printer. Unlike a 3D printer, my machine does not add material to make parts, but rather removes it. It does this by using salt water and electricity to dissolve away material electrochemically. This does not apply any force to the part, meaning that small and precise features can be machined. And it is effective regardless of the mechanical properties of the material, meaning that even metals that are normally too strong to cut can easily be cut with my machine. I designed and built essentially every component of the machine, except for the frame, which came from a 3D printer. The primary components of the machine are as follows. The tool, which is the component that is used to remove material. The tool can move in 3 axes, which allows it to cut a multitude of different shapes. The control system, which controls all movement of the machine. I designed the control board myself and wrote my own firmware for it. The pump, which I also designed and manufactured myself, which dispenses electrolyte into the machining zone, allowing machining to occur. And the filter, which filters out waste from the outgoing electrolyte stream. Imagine being able to create a discontinued part for your car, extending its life by another 5 years. A doctor in an under-resourced community, creating medical devices that are needed but inaccessible, or a student at the science fair, manufacturing a custom part for a groundbreaking new invention. If you could make anything out of any metal, what problems could you solve?